Okay, we have another question. It's called exercise 2 or a question 2. That one we were going to solve by using Gambit. Before that, this is the Gambit software. Anyone have difficulty when running Gambit, or anyone already tried to run in Gambit or not? Okay, never mind. I will ask afterward. Okay, so wait wait. Okay, so first of all, this is Gambit. We can call the main page. So here we will have as I've mentioned previously, we have two types of metrics. Either we are using extensive way or matrix way. Okay, the first one called extensive or three game diagram. Next is matrix or table game diagram. Okay, here we can always currently they will have minimum two player. But if you want to add more player, you just can click here. Okay, you can just click here and you can get a new player. And if say you don't want to have that you only want to stick to one player, you just can click, always can click to one, either extensive or strategic game. Okay, let's look on the extensive game first. On the extensive game, we know that we will have the follower and leader. So first of all, when we have the first one will refer to the follower, sorry, the leader. So in the leader, you just right click and you put here the insert move. When you click insert move, they will ask, is it insert move for player one or for player two or for a new player? So for this case, we will start for player one. Just click the player one and click OK. Okay, when you have the player one, you can see now your main node is called 1 1 because it just refer to the first node that refer to the first player, which the first player will have two strategy, either strategy one or strategy two. So if you want to add, let's say you want to add for player number two, in this diagram, you just right click it back and click insert move. When you insert move, now it's still at the new information set. Is there because we are going to use the second player. The second player. So when you have the notes for the second player, you just click OK at a new information set. Then you can find that you will start to have a new strategy that play by node number two or player number two. Okay, player number two. And let's say if we are going to have another player two that playing a new information when player one playing the second strategy, you also can just right click it and insert it, move and click OK. Okay, and click OK. And up here, at here, you just can double click it. Okay, double click it. The first value refer for the player. The second value will refer to the first value will refer for the first player, and the second value will refer as usual for second player. Let's say 0, and let's say another one is 1. So if you look here, we know that when when so it means that if when we look at this game, okay, player one we play when player one will play the strategy number one, and player two will play according to strategy number one that by sorry again. So when player one will choose strategy number one, and player two will follow the strategy of one, so the player number two will have the value for when player number one play one and player number two play the first strategy. The value of the payoff will be 0 and 1. Okay, 0 and 1. And let's say for this particular this one, the blue color is referred to the second player, and the red color refer to the first player. Okay, now I'm going to ask you, Ahmad Arif, are you there?
Yes, doctor.
Sorry, Ahmad Arif. Okay, Ahmad Arif, what the second excessive game explain to us?
Sorry, doctor. Uh,
For this particular strategy, when player one using the second strategy,
mhm.
is it this is note that play by player two or player one now? The second one.
uh, the second one is played by the player two.
No. Look at the color there.
Oh, okay. Player one. Still player one.
So you get it or not? So
Yeah.
it means that when you have the same color, it means it's still played by the second the same player. Understand or not?
Oh, okay. Okay,
Okay,
doctor.
let's say if I have another player, I add a new player and I call as player number three. So let's say here I want to put player number three. When player number one plays second strategy and the player number one still playing as the first strategy. So let's say I insert the move, then I put here for player number three. So I just put here player number three. So then click OK. Now you understand or not? Arif?
Oh, okay. So every time I want to insert a move, it depends on like for the color will correspond to the
Yeah, the
player lah.
color will correspond to the
Oh, okay.
player. Can you get it or not?
Okay, doctor.
Okay,
Yes.
so thank you so much, Arif. So this is how we should arrange our player in extensive form. And as I previously mentioned to all of you, basically we can convert back that extensive game to the normal form. But that one I don't want to teach today yet, since we did not understand what means of complete information. And when you already start to add another player, automatically you can see here you have another column that shows the value of the third player. That's why in this game you get 0, 1, 0. Okay, 0, 1, 0. I know, boleh faham tak? No. Halo, I know, ada di sana kah? Tak ada. Okay, it's okay. So this is how we're going to arrange it in the extensive form. It's accordingly what the strategy play by each player. Okay, let's now look at the another form. Okay, let's say I don't want. So let's look with another player now. We play, just now we play extensive tree diagram. Now let's look on the table form. When table form, you will have a minimum 2 by 2 player. Okay, minimum 2 by 2 player. Then you also will have player one and player two. And let's say if you want to add another player, you just click another player and automatically it will give the answer here. It means that the player one will play one or two. Player two will be playing one or two depending on the play. And player three also will playing one or two. Okay. So, but do remember in uh, when you arrange it into the table form in the Gambit, you need to make sure the table tree, sorry, the player tree, the value of the player tree always will be inside. Okay, always will be in the middle. Okay, always will be middle. And the good thing of the Gambit, why I'm purposely teaching today, because we can use this one for more than for more than two players. Let's say I want to add around 6 players. Okay, the value, when you have the value always go to the middle of in the software. Okay, so this is a good thing. And when you already put the value, let's say you already put the value for every player, and you're going to find what will be the dominance. Okay, what you can do here, you just compute. Okay, after you put the value or insert the value accordingly. Do remember, when you did not use the value accordingly, the answer or result that you get will be different, or in other words called wrong. Okay, so this is after you insert the value, we just need to compute. We just click the calculator icon. When you have calculator icon, you they will ask you either you want to compute one Nash equilibrium or compute as many Nash equilibrium as possible. As mean one Nash equilibrium, it means you might be get two in when you're doing manually, when you're playing two by two. Let's say when you're playing two by two or three by three. Let's say you have two Nash equilibrium, but when you're choosing only one Nash equilibrium, they only give that one particular equilibrium. It might be same like you or doesn't seem like, or doesn't it should be same. One of the values should be same. So if you don't want to compute the Nash equilibrium only as one, or you want to have as many as possible, you just compute as many Nash equilibrium as possible. If you look here, this is, we have three method. Okay, here we have three method. First is by using Gambit recommended method. Second is simple subdivision or tracing logic equilibria. You no need to use tracing logic equilibria because this is already on higher level, which I did not touch for undergraduate. Okay, for simplical simplicial subdivision is actually referring to your linear programming. If you still remember on your uh, first course in the linear programming, you will have like when you have 3 to 4 equation, you only to take the equation that satisfy all the condition. So it's the same thing when you have want to use by simplical subdivisions. They only take the particular condition that fulfill all the criteria, and they will take that value. But for our case, we no need to look at the simplical subdivision because we are just using Gambit recommended method. Gambit recommended method definitely is regarding Nash equilibrium. Okay. And a good thing, another good thing here, if you look, okay, because maybe this one, because we did not compute the value yet, we will look afterward. We can get another point here. Did you want this one, the first one, compute one Nash equilibrium. Second one, compute as many as Nash equilibrium. The third one, compute mixed strategy equilibrium. They will have another one called mixed strategy equilibrium. Or finally, calculate all the equilibrium. All equilibrium means here including pure and mixed strategy. And do remember, for you need to understand well about Gambit because one of the question for midterm that I already prepared, not prepared yet, I already think is using Gambit. So you need to use Gambit. And definitely I will try to make sure not the same value for every of you. Every of you will have a different payoff. Okay. So definitely we're going for the n percent game for when we are using Gambit. Okay, so when then next time you just click OK and you get the value. But for this case, you will never get anything because we did not put any value yet. Okay, and it will take some time to compute and do the computation. Okay, wait, okay, maybe because it doesn't have value, that's why sometimes it just close like that. So never mind, we open back our Gambit. Okay. So let's look at, I already told you what is the, okay. This one is already explained to you that if when you have excessive form or we have uh, table form, we always can use compute Nash equilibrium of this game, or we also can look at, okay, I don't have here. Okay, if you look here, we also have another thing called display the reduced strategic representation of the game. Basically, what this is about after you, let's say you have 5 to 5 games or 6 by 6 games, you want to do elimination method. When you can see there is elimination method, or if you feel that there are so many players in the game, why not I just want to use, is it there is any elimination method so that I can reduce the size of matrix? You can do it by just click this one. After you have the originals, value diagram, let's say you have 2 by 2, 3 by 3, 4 by 4, or n by n, you just can click this one, and they will help you to give you the reduced metric, and they will specifically let you know which matrix is eliminated. And do remember, the good thing when you're using Gambit, okay, when you using Gambit, you will have a dominance rule. Okay, dominance means a dominated strategy. And here you need to understand, I only teaching all of you on strictly dominated. Okay, on strictly dominated. It means if any in every column, the value, all the values should be more more than another column, so that we can eliminate the letter column. And that's called strictly dominated. But if weekly, let's say, got three value, which is higher the value than compared to other column, but got one or two value is equal value or lesser value. Okay, lesser value, we call that one as a weakly dominated. That's one also we can use our Gambit to solve the issue. If we want to look on dominated strategy, or we want to look at the strictly dominated strategy, or we want to look at weakly dominated strategy. And here the good thing of Gambit also can show which strategy that refer for strictly dominated or weakly dominated, and they also be shown all the strategy that may be involving of strictly or weakly dominated. Next, we also need to understand another important things regarding the Gambit on tools. Okay, on tools. When click tools, we have three things. One is dominance. Second is equilibrium. The third one is QRE. QRE is means the quantum response game. Counter response game, I always use counter response game, not Gambit. I'm using Python or R to solve a lot of recent issues such as traffic, CCTV data, crime scenes in Malaysia. And I'm using contact response game, which is much more higher compared to equilibrium and dominance. Basically, when you have contact response game, we're already involving on evolutionary game theory. Okay, evolutionary game theory. And the good thing about contact response game will be explained of Associate Professor Dr. Mijano Rahman on Monday. Okay, so when you are talking about Nash equilibrium, you can use either extensive or strategic games. Okay, let's look one example. Okay, if you still remember, okay, I will show you. Okay, let me go to the a new. Let's say I'm using strategic game, and I will show you. Okay, the value. Okay, actually I already give in the video. Let's say now we have 8, 7, 4, 6, 6, 5, and 7, 8. Okay, let me call someone. Lukmana, are you there? Okay, what the first is it have any Nash equilibrium in the pure strategy for the matrix form? Which one? Y 8, 7. Okay, let's say if okay, if let's say 8 compare 8 compared to 6, is it, or 8 compared to 4? Okay, 8 compared to 6 and 8 compared to 4. Okay, so which one? Okay, you are saying 87, is it? Okay. Okay, so next, thank you so much. Uh, okay, let me call another person to confirm the value. Okay, Wong Siu San, are you there?
Yes, doctor.
What will be the pure strategy for this game for the first matrix?
My answer is 7, 8.
Okay, why your answer is 7, 8 and not 8, 7?
Uh,
No worries,
because
we can
it's,
discuss. No worries, just discuss it. Susan,
because it's the higher payoff.
higher payoff. Okay, thank you very much, Susan. Let me call another person to confirm the result because now we have two different results. Wong Yu Guan, are you there?
Yes, doctor.
Hi, boy. Good
Uh,
afternoon.
Good afternoon, doctor.
What will be the equilibrium for the this matrix, boy?
For me, it's 8-7.
8, 7.
Uh,
Why not 7, 8?
because of the same reason as Lokman said just now, the
Okay.
dominant strategy.
Okay, let me call. Thank you so much, boy. Let me call the
Okay,
final
thank you,
one
doctor.
person. Okay, let me call another person to confirm before we use Gambit. Let me call. I want to call someone. Jason, are you there?
Yes, doctor.
Hi, boy.
Hi, doctor.
Okay,
Um,
what will be the answer, boy, for this particular matrix?
for me is 8-7.
8, 7 also, right? Not 7, 8. Okay. Okay, let's put the value here. Okay, do remember the first value will refer for the first player, and second value for will refer for the second player, 8. You also can do together with me in your particular Gambit software. So let's say 7. So 4 and 6. Next is 6 and 5. Finally is 7 and 8. Okay, so I hope the value is same. So next, what we can do, we can just click either to use, let's say, compute, let's say if I want to look on the one, compute one Nash equilibrium, and I just click Gambit, it will show me the value of 1 and 2 and 2 and 2. Okay, so number of equilibrium found so far, 1 you can find is 1 and 2. 1 and 2 refer to 4 and 5. Are you sure? Another one, 2 and 2, 7 and 8. Okay, why? Anyone? Wait. Okay. Huh? Anyone know why is get a 1 and 2? It means that the player that playing for first player go 1 and 2, 1 and 2, another one, 2 and 2. It means 7 and 8. Another one is 1 and 2. 4 and 6. Anyone?
Doctor, I don't understand.
Yeah, yeah. Huh? What?
I don't understand how to interpret what
No, no, no,
the
no, no. Wait, wait,
Gambit
wait.
software is saying, doctor.
Oh, no worries. Thank you, Amarif. Okay, look here. When you already click Gambit, right? Okay, wait. You understand or not until how we insert the value?
Yes, doctor.
Okay,
Just
when you already
after the computation. I don't know
yeah,
what that
after you
thing means.
good, good. Thank you, Arif. So when you already insert the value, when you click here, it will show you what the value of the player one and player two. Hello? Arif?
Okay.
Okay, for this one, player one, the payoff will be 7. And player 2 will be 8. Just now, three of you saying that we will this one is this one will be one equilibrium. 7 and 8. Okay, when you are already, okay, let's do it together again. Okay, when you already put the value 8, 7, 4, 6, 6, 5, 7, and 8. Okay, so then you just click on compute Nash. First of all, it doesn't show any value here for player 1 and player 2. With Gambit, it will calculate and show you that the value will be 7 and 8. 7 and 8 means here the first player value will refer to matrix number 1, 2. Okay, 1 and 2. While for player number 2, we refer for the matrix 2 and 2. So here it shows that 1 and 2, 1, 2, right? Yeah, 1 and 2. Okay, 7 and 8. Okay, but we just now for the the discussion, we have 8, 7 uh, as the what we call Nash equilibrium. But one of the girl mentioned 7 and 8. Who is just now explaining 7 and 8? I forgot the name.
It's me, Dr. Susan.
Why you are saying 7 and 8, girl, not 8 and 7?
Uh, I do it using Gambit.
Oh, no. If let's say if logic thinking, logically, did you still get 7 and 8?
Uh, yes.
How? Explain. When let's say player 1 playing the first strategy.
Yeah, when player one playing the first strategy, then player 2 will choose the first one.
The first one, this one.
Yeah.
Okay.
When player 1 playing the second strategy, player 2 will choose the second one.
Second one means what? Which one?
The 2-2.
The Tuto 8.
Yes.
Yeah, correct.
Yes.
So in either playing this one and this one, correct or not?
Yes.
Okay. Then player 2, when playing first strategy,
Then player 1 will choose the 1-1.
1, 1, 8.
Yes.
Okay, good. The final one?
When then player 2 will choose player 1 will choose 2.
Very good. Now, Lukmanul, Jason, and another one who just now? Got three
Me,
people.
Jungwan.
Jingwan. Can you understand or not? Jason?
Yes, understand.
Understand or not? How you get 7 and 8? Look, Ahmad, Arif,
Yes, doctor.
boleh faham tak? Maksudnya, when player 1 choose strategy number 1, understand or not? For when
Yeah.
player 1 choose strategy number 1, we choose either 7 or 6. Which one you will choose?
7.
7. When playing strategy number 2, we choose 5 or 8.
8.
8. When playing strategy for player 2, when playing strategy number 1, because we look at the column right, is it they will playing 8 or 6?
8.
For player number 2, when playing
7.
7, which one got both together?
The 7 and 8.
Faham tak?
Yeah. Logically, yeah, lah, doctor.
Yeah, that's why you get 7 and 8. Arif?
Okay, doctor.
Boleh faham tak, Arif?
Yes, doctor.
Boleh ya?
Yeah.
Okay, good. So good. It's actually very good. Because if we, this one, the profiles means when they are player 1 choosing player number 1 and 2, 1 and 2, they will have higher payoff. Higher payoff, and actually it's already not higher payoff when playing between 6 and 7. And for player number 2 is 8. Okay? Apa yang saya cakap ni? Sorry. For player number 1, they will play 1-2, 1-2, and player number 2 will play 2-2. Okay, now try to do. So this is how you get. This is a very simple one. Okay, this is we're still playing on 2 by 2. Try to do number 2. I'll call someone. Try to do. I will continue the class until 1:20. Just give me until 1:20 because I really hope we can learn the Gambit today. Please, please, and please. Just give me around 1:20 to 1:25. Enough already. Okay, so for second question, I'm going to call someone. Let's say I don't want to save. I basically you also can save. You just go through whatever that you can do in that game. Okay. Okay, let me open another one. Okay, for second question. Try to do the second question. 9 and 9, 1, 10, 10 and 1, 2 and 2. If logically, if you look here, let me call someone. Lim Min Jun, are you there?
Doctor, sorry, I do have a question regarding question 1, Doctor.
Okay, what girl?
About the Nash equilibrium, based on what I understand, wouldn't it be two cells, which is the Nash equilibrium, Doctor?
Which one? Yeah, two cells. If you look for the first question, girl. Okay, let's look back.
And also, from the interpretation of just now, I couldn't really understand what's going on.
Okay, no worries, girl.
Okay, thank you, Doctor.
No worries, thank you. Wait, let me go back to the question 7 and 8. Okay, so this is the value. The first value refer for the first player. The second value will refer for the second player. Wong Siu San, are you there?
Yes, doctor.
Okay, can you explain again clearly to our friends here how you get the value?
Oh, okay.
Okay.
So
Let
when
me
player
see.
1 playing strategy 1,
Okay,
player 2
when
will
player 1
choose. Yeah.
when player 1 plays strategy number 1, they just can choose row or column.
Uh, row, say
Row, right?
7. Yeah, 7. You will choose.
Okay. So listen here. When you're playing player 1, sorry, this is referred to player 1. When you're choosing the value for player 1, we will choose the value between what value, girl? 8-4 or 7-6?
7, 6.
Why 7-6?
Because it's for player 2 to choose.
Okay. Mushida boleh faham sampai sekarang tak, Mushida?
Yeah, I do understand about that, but then when it comes down to the conclusion of the Nash equilibrium, I couldn't understand why
Can.
it is chosen to be 7, 8.
So can. Thank you, Mushida. So this one you can get it right. How you get 7 and 6?
Yes, Doctor.
Okay, the second one, which one you will choose? 5 or 8?
8.
8. Now you understand the first dominant for if playing for player so if you're playing you will get 8, correct or not? Second, for player number 2, you need to choose either 8 or 6, definitely going for 8, correct or not?
Yes, Doctor.
And another one you will choose 7, correct?
Yeah.
Okay, so if you look here, we get how many equilibrium?
2.
2, right? But
Yeah.
just now, what I'm doing here, I just look at the one particular Nash equilibrium. I just compute one. Understand or not?
Okay.
Mushida? That's
Yeah.
why one of the equilibrium that I get here is 7 and 8. Boleh tak?
Why, Doctor?
Huh? No, because this is only one equilibrium. Although you got 2, in this case, I just put here compute one Nash equilibrium.
But is there a reason why it's chosen as
No.
7,
It does
8?
not have any reason. Sometimes when we have a lot of equilibria, you just click here, as many as equilibria possible.
Oh, okay.
Understand or not? So
Hmm.
this is they already give including the mixed strategy. I just want to bring one Nash equilibrium first, girl, because I have 4 questions. Then I thought I want to bring what will happen when we have many Nash equilibria. For time being, I just teach how if you want to get one Nash equilibria from Gambit. Can or not?
Okay, doctor.
Okay, so all of you, thanks to Mushida. Thanks to Mushida. When you're doing this one, you always can go, if you want to look at the one Nash equilibrium, compute as many Nash equilibrium or compute all Nash equilibrium. Okay, okay. So that's why just now what I do here, I just calculate one. Actually, for this case, we have two. Okay, so let's say if we want to go as many as Nash equilibria possible, definitely it will give you including the what we call including the mixed strategy. Including the mixed strategy. One Nash equilibria you have in 1 and 1, which is 8 and 7. The second one you have in 2 and 2, it means 7 and 8. Okay, 7 and 8. Next, you also will have the randomized strategy of each matrix if you are using P and 1 minus P, Q and 1 minus Q. Get it or not? Okay, so try to do for second question. Try to do for the second question. Quick, I only have another 6 minutes.
Doctor, the second question, right?
Ah,
Can
Siapa tu? Oh,
do,
Arif. Yep, yeah,
yeah,
Arif.
can do, but I don't know how to interpret the answer like that. Like,
Okay, so did you already put it into the value or not? Okay,
yes,
okay. Let's say Arif, we did not use the gambit yet because this by 2 by 2 still easy, correct or not?
yeah.
Okay, okay. What the equilibrium that we get from this study? From this particular matrix.
I think it's 2 and 2 and 9 and wait, no, 2 and 2, just 2 and 2.
Okay, let's say if you're playing strategy number 1 for player 1. Okay, are you going to choose 9 or 10?
Going to choose 10.
Correct or not?
Yeah,
So when playing 1 and 2, definitely 2, correct or not?
yeah.
When playing player 1, strategy number 1, are you going to play 9 or 10?
I'm going to play 10.
10. 1 and 2. So the only
2.
left equilibrium is 2 and 2, correct or not? In the
Yeah,
pure. In the
yeah.
pure. Okay, so let's look in our calculation. What is the value here? 9 and 9, right? 1
Yes,
and
that's right.
10, correct? Second one, 10 and 1.
10, 1, and then 2, 2.
2 and 2. Wait, okay. So let's say we use, let's say, all Nash equilibria. So in this equilibrium, what you can find on the all Nash equilibria is 2 and 2, correct or not? 2 and 2, correct?
Yeah, logically, yeah.
That's
Wait,
why you
the
have 2
2,
and
2
2.
means that, doctor. The 2 dot dot 2 means
Is that the matrix number? The
is,
player 2 we play the strategy number 2. You will have,
oh, the
like this
1
one.
represent what? The
Okay,
one below the 2 dot dot 2. That one.
okay, the one will choose as a expected payoff. Expected Nash equilibrium payoff. Let's look here, yeah. 1 and 1. 1 and 1 is 0. 1 and 2. Wait, wait. 1, 2. 1 equilibrium. 2 and 2, another equilibrium. Okay, so the 0, 1, 0, 1 here refer for which expected value, payoff value chosen. Example, for player number 1, they will choose player 1 playing strategy number 2. Understand or not? Right?
Player
Player
one.
one. Okay, the first one refer to the player. Okay.
Okay.
The second dot after the this one, the second value here refer for the which strategy that they are using.
Oh, so that one player one using strategy one like that.
So, yeah. Example, the value one here down here shows which value is selected. Understand or not?
Oh, which value is selected? That means
Okay,
referring to the table. That means
yes,
the
correct.
one lah, the 10 and 1.
Which one? No. It means that in this equilibrium, because they are competing equilibrium, they are saying first player will always choose two. Understand or not?
Okay.
Player two
Oh,
will
okay.
always choose two. So the only value have in the two and two is two and these two. Understand or not?
Oh, okay. I mean, wait, how did they get the 2 and 2? Where to get that from the Gambit? Like, I
No,
understand
they
the.
already have the algorithm, boy.
Oh, okay.
This is software, boy. They already have the algorithm inside the software.
Oh, okay. No, I mean the 2 is from the answer payoff there, right? The
Yeah.
2 2.
So that's why you get two and two, and actually this answer is correct if you are doing manually. Correct or not?
Yes, doctor.
Boleh faham tak?
Yes, doctor.
Okay. Mushida, okay, right? Mushida?
Digesting, doctor.
Digesting. Okay. So we got another 6 minutes. Okay. I will send this one. Try to do afterward. I want all of you after do this 4 question. If you still remember, I have given you in the lecture. And no, not this one. In the lecture, this week, last week, on exercise 2, they are taught regarding 3x3 matrix. Okay, 3x3 player. So try to do it. Once we already finish this Friday talk, after finish our class on Shapley, after finish the talk, if we still have the time, we will discuss it. If not, I will do a video in the loop. Okay. Sorry again for today's. It's about internet here. We does not. I doesn't get internet from 12:40 until 11:40 until 12:30 something. So that's all. Thank you very much for today.
Thank you, doctor.
Please try to do. Yeah. Please try to do.